Before I start exercise 4b2, um, I wrote this equation, quadratic equation x plus b, x, x plus r, x plus t in this form. And if you see that ax4, uh, a is the coefficient of x4, if a greater than 0 and a less than 0, this is a rough idea what is going happening. Now, if we have four roots, then if a greater than 0, it is going to be something like this. And if it's a less than 0, those are the four roots, but graph goes down. This is graph up. And here you can see three roots. What is happening here? One root is repeated. Then this repeated root either can be left from those roots. So then you will get this kind of a graph. Or in the middle, then you'll get this kind of graph. Or in the right side. So this is the repeated root, these are the normal roots. And they, since a greater than 0, they are all going up. And same a less than 0, so, and this is at repeated root, the curve touch the x-axis. Repeated root when we have a square repeated root. Cubic is different. It is a point of inflection. Now it is less than a less than 0, it is going to be this kind of graph. So the repeated at the left from those two. In here repeated is in the middle. And here repeated is at the end from those two. But graph goes down. Then x plus b square, x plus q square, both are repeated root. If a greater than 2, both are repeated root. So then you can see that one. The curve touch 2 times x-axis upward. And a less than 0, curve touch 2 times x-axis downwards. Now, this is how you can see point of inflection again. X plus v cube root. Not root, x plus v to the power cube, third. 3 times the root is repeated. Now this 3 times repeated one may be in the left from the other one. Then this is a point of inflection, write this. A greater than 0 for this one. Or it can be in the right side from the this one. So it can be something like that. The same way opposite, when a less than 0, this is the repeated root 3 times, and this is the other root. And if the repeated root in the right, so this is the from this point. So this is this one. So this is a point of inflection. Here the curve touches the x-axis. Here also same. When you see p square cube, then cubic power, it will point of inflection. If it is 1 power, it will cut. Square touch. Square touch. Inflection, third power, point of inflection. And 4 again, it is a touch in. If a greater than 0, all the roots are here. Here a less than 0. This is a rough idea about this quadratic graph. Now this is question number 2, part A. Um, this is the question, and if you see a quadratic equation, we want to see that whether we can, this one is bracket out. You can see that you can break this one into x minus 1 and x minus 2. Then this become x plus 2, x minus 1 square, x minus 2. So now you can see that the repeated root in the middle and a is greater than 0. It will we are expecting this kind of graph. This is minus 2, this is 1, and this is 2. To find roots, y equals 0, then x plus 2, x minus 1 square, x minus 2 equals 0. X plus 2 equals 0, or x minus 1 square equals 0, or x minus 2 equals 0. Then x equal minus 2, or x equal 1, or x equal 2. So minus 2, 0, 1, 0, and 2, 0 are the points, the roots. Now, when x equals 0, y is, I'm going to substitute here, 2 minus 1 square minus 2, which is minus 4. So 0 minus 4. When x goes to positive infinity, y also goes to positive. When x goes to negative infinity, y still goes to positive. Now we'll draw the graph. Minus 2, 1 is 1, 0, another one is 2, 0, and minus 4. Which one is the repeated? So we have to touch this one. We have to start from here and end from here. Y, x, this is 1, 0, this is 2, 0, and this is minus 2, 0. This is 0, 0, and this point we have to mark 0, minus 4. Sketch is done. Part B, x plus 3 square. Can I bracket this one out? Yes. X minus 2, x minus 3. Y equal. Now to find roots, we want to make y equal 0. Equal 0. So x plus 3 equal 0, or x minus 2 equals 0, or x minus 3 equals 0. X equal minus 3, or x equal 2, or x equal 3. So minus 3, 0, 2, 0, and 3, 0, and this one is a repeated root. when x equals 0, y equal, I'm applying to here, 3 square minus 2 minus 3. 9 times minus minus become positive, 54. So this one is 0, 54. Now x goes to positive infinity, y goes to positive, and x goes to negative infinity, y still goes to positive infinity. Now we'll draw the graph. Now minus 3, 0, 2 and 3, and graph go through 54 somewhere here, and this is going to be a curve touch at minus 3 because repeated root. So we'll start from here, go like this and come like this and go again. So this is 3 0, this is 2 0, and this is 0 0, and minus 3 0, and this is 0 54. Part C, x minus 4, and let's see whether we can bracket this one out. Factorize this one, x minus 4 square, 6 times 5, x minus 5, x minus 6. Now we can see this is a repeated root. So when x equal 4, it will touch the axis. X equal 5 and 6. And x square is positive. 4, 5, 6. So I'm expecting x equal 4 touch, and like this is 4, 5, 6. This is the graph basically. To find roots, you want to make y equal 0. Then a minus 4 x square, x minus 5, x minus 6 equals 0, x equal 4 or x equal 5 or x equal 6. So the root coordinate of roots are and 6, 0, and this is the repeated root. And when x equals 0, y equal, I apply here, minus 4 square minus 5 minus 6. 16 times 30. 160 times 3, which is 480. So 0, 480. And x goes to positive infinity because coefficient of x 4 terms is positive. Y also goes to positive infinity. X goes to negative infinity. Y also goes to not negative. Y goes to positive. Still y goes to positive. So, okay. This is 4, 5, 6. Tough one, and this is 480, and this is going to be a touch because that is the repeated root. And so this is going to be 0, 480. and this is 4 0, this is 5 0, and this is 6 0, and x-axis and y-axis. Part D, two quadratic equation. Let's try to factorize this one as usual, and this is 8 times 4, x minus 8, x minus 4, and this is 9 times 4, uh, x minus 4, x plus 9, x minus 8, so minus times my, so this is, has to be 4. Now minus times, this is 9. I will rewrite like this, x plus 9, because this is going to give minus 9, then x plus 4 minus 4, left to right, then x minus 4, 4, x minus 8. Then to find roots, we want to put y equals 0, then x plus 9 times x plus 4 times x minus 4 times x minus 8 equals 0, x equal minus 9, no, x plus x equal minus 4o, x equal 4o, x equal 8. Now 9 0, 4 0, minus 4 0, and 4 0, 8 0, 4 roots there, and no 0 0, then when x equals 0, y is, and put into this one, 9 4 minus 4 minus 8. Thirty-six times 28. This is 1152. And power of x 4 times is positive. Hence, x goes to positive infinity, y also goes to positive. X goes to negative infinity, y still goes to positive. So 2 here, 2 after this one, 4 and 8, and 1152 here, 0 1152. Since it's positive, if we start here and here, if we start here, then in this place. Zero, and this point is minus 4 0, minus 9 0, minus 4 0. This point is 4 0, this point is 8 0, and this is 1152, 0 1152.